In this video, we're going to be calculating the estimated mean and the estimated standard deviations. So, ladies and gentlemen, you are always going to be given the class interval column and the frequency column. And I'm going to take you step by step on how to get each and every individual column here. First, before we can calculate the estimated standard deviation, we firstly need to calculate the estimated mean. And the estimated mean, we need to get the midpoints first. So this column here, we must get it on our own. And this is how we're going to get it. We're going to say 0 plus 10, which gives you 10. And then you divide that by 2, which will give you that 5. You do the same. 10 plus 20, that's 30. 30 divided by 2 is 15. 20 plus 30 gives you 50. 50 divided by 2 is 25. So you always add those two numbers and divide by 2. That should give you the entire midpoint column. Right. And then we need a column of frequency multiplied by midpoint. This column, you are just basically going to be multiplying this midpoint with the corresponding frequency. So 5 times 20, it's 100. 15 times 36 must give you 540. 25 times 32 must give you 800. 35 times 8 must give you 280. 45 times 4 must give you 180. Alrighty. And then, ladies and gentlemen, the formula for the estimated mean is the sum of the products between the frequency and midpoint divided by the total number of items which are there. In simple terms, the total frequency. So I need to know the total of the frequency because it's my divisor on the estimated mean. It's what I'm going to be dividing with. So I have to add all these 5 numbers, and that gives me 100. Which means the total items which were there were 100. And then I have to also add this guys here, the product between frequency and midpoint. And that gives us 1,900. So the estimated mean is the sum of the products divided by the total number of things which are there, or the total frequency, which is 1,900 divided by 100, and that gives us 19 minutes. Alrighty, perfect. So now to get the estimated standard deviation, we firstly need to get the deviations between the midpoint and the estimated mean. So you know that your x bar is 19. So you're going to take each and every midpoint and minus 19. So for example, 5 minus 19 will give you negative 14. 15 minus 19 will give you negative 4. 25 minus 19 will give you 6, and so on and so on, right? But we need the deviations square. We need everything to be positive, right? So this squared will give you that. That squared will give you that. That to the power 2 will give you that. That to the power 2 will give you that. That to the power 2 will give you that. Awesome. And then now we need the product of the deviation squared and the frequency. So we take the frequency, we multiply it by the deviation square. 20 times 196 must give you 3,920. Then you take 36, we multiply it with this one, it should give you that one. You take this one, you multiply it with that one, which should give you that one, and so on and so on, right? Awesome. And then you need the total of this column, the total of the product between frequency and the deviation squares, and that gives us how much? 10,400. So now the formula for standard deviation is basically the total. We're going to use the sample deviation formula, no? Perfect, because we're doing the estimated standard deviation, right? So we're going to say square root, right? Because basically this formula here is for variance, no? But we need to square root it because we are looking for the standard deviation. And we can see that here we need the total of the product between the deviations and frequency all over the total frequency minus 1. So the total frequency was 100. When we minus 1, we get the 99. And then the total product between frequency and deviation squared is 10,400. And then that should give us a standard deviation that is approximately 10.25 minutes. Thank you very much, ladies and gentlemen.